In this video, we prove the following result. 2 is a quadratic residue of a prime p larger than or equal to 3, if and only if p is congruent to 1 or minus 1 modulo 8. So the first step of the proof is a Newton expansion. So I expand 1 plus I to the power p, and then I take the real part. So I get real part of sum k equals 0 to p choose k, so it's p factorial over k factorial p minus k factorial times I to the k. Like take the real part. So I can write as a sum p factorial over k factorial p minus k factorial times real part of I to the k. And I look at this real part modulo p. So if k is different from 0 and p factorial is divisible by p, but not k factorial and p minus k factorial, because p is prime, and these two factorials are product of numbers smaller than p. So the factorials are not divisible by p, so the denominator is not divisible by p, but the numerator is divisible by p. So the fraction, the ratio, is divisible by p. So all terms are divisible by p, except for k equals 0 or p. But for k equals p, the term is also 0 because I to the k is imaginary, because p is odd, so I to the k is I to the p, so I to an odd power, so it's imaginary, and then the real part is 0. So I can also discard the term k equals p. So the only remaining term, which is not divisible by p, is for k equals 0, and the term for k equals 0 is just equal to 1. So I get that the real part of 1 plus I to the power p is congruent to 1 modulo p. Now, on the other hand, I can also use the trigonometric form of 1 plus I. So I write real part of 1 plus I to the p is real part of square root of 2 exponential I pi over 4 to the power p. And then I expand my power, so I get real part of 2 to the p over 2 times exponential p I pi over 4. And then the real part is 2 to the p over 2 times cosine of p pi over 4. So if p is congruent to 1 or minus 1 modulo 8, p pi over 4 is congruent to pi over 2 or minus pi over 2, modulo 2 pi. And then the cosine is 1 over square root of 2. So the real part of 1 plus I to the power p is 2 to the p minus 1 over 2. And then, by the previous congruence, 2 to the p minus 1 over 2 is congruent to 1 modulo p. And similarly, if p is congruent to 3 or minus 3 modulo 8, the cosine is minus 1 over square root of 2, and then the real part 1 plus I to the p is minus 2 to the p minus 1 over 2, and then 2 to the p minus 1 over 2 is congruent to minus 1 modulo p. And then we can conclude by using Euler's criterion on quadratic residue.